right, let's get started. So I had a meeting with my TAs Monday, which I do every Monday. Asked them what I needed to know about how the class was doing, and one thing was that I should remind you about academic misconduct. So, just as a reminder, these problem sets are not group assignments. You do not sit around one computer and come up with one solution and hand in the same solution to everybody. You do not sit in class side by side with your laptops open and do this while the TA is sitting behind you watching you do it. You shouldn't do that whether the TA is watching or not, but doing that in class while the TA is watching is real hubris. Don't do that. You can talk to other people, you can collaborate to the extent that you talk about the assignment and kick around ideas. But when it comes to writing code, it needs to be your own code that you conceived of and typed in. Okay? It's not code that you get off the web. It's not code that that your friend wrote or that you and your friend wrote together. It's your code. Okay? Is there any questions about that? Yeah.
So, if I'm trying to investigate maybe like one specific thing, like I want to know how to do something, is it okay to like look online and maybe take that one tiny piece, like one line of code, and implement it in my code, which usually almost does completely something else?
Well, okay, so what he's asking is, to what extent can you Google things that you don't know how to do? And if the assignment is write a method that reports whether a string is a palindrome, you may not Google how do I test whether a string is a palindrome and copy it and hand it in. If you're writing code to detect whether something is a palindrome and you Google how do I get character I out of a string, that's fine. Okay, so if there's something about the language you don't know, look it up, that's fine. But don't Google the whole thing. That help?
Yeah, I basically was doing what you said is okay, just finding one thing.
Any other questions? All right, another thing is a lot of you are doing really well, but a few of you are really struggling. Because I go over all the submissions and look at how many test cases were passed and such. And there's a good chunk of students that need more help than they're getting. And we can't drag you kicking and screaming to us to have us help you. But I would say that if you've gotten low grades on PS2 and we're about to release PS3, that should be out tomorrow. If you're you should know whether or not you're struggling or not. Come to my office hours, make an appointment with the TA on Monday, Tuesday, or Wednesday, and just go talk about PS2 and PS3. Find out what you did wrong, how you could have done better. Because if you don't do that, it's not going to get any easier going forward. You've got to, if you struggle on PS2 and PS3, that happens, but learn from it. And you're not going to learn from it unless you go ask for help. So do that. Going forward, so PS4 A and B are due tomorrow or Friday with a late day. PS5 will be due the next week, and PS6 will be due the following week, which is the week before fall break. So by fall break, you have completed 6 problem sets. The midterm will be on the Wednesday after fall break. So there'll be a week off. The first full week in October is fall break. Then October 16th is when the midterm is. There won't be anything due that week, so there'll be no problem set 7 due that week, and there'll be no ZyBook assignment due that week. All you've got is the lecture on Monday, the lab on Tuesday, and the midterm on Wednesday. So there'll be sort of 2 weeks with nothing due, counting fall break. But midterm will cover everything we do before fall break, so everything through PS6 and all the ZyBook before fall break and so on. We'll do reviews in lecture on Monday, October 14th. I'll do a review. The TAs will do a review in labs on October 15th. I'll give you a sample midterm, an old midterm, and the TAs will be going over that in the lab. That's what their review will be, is going over the solution to that midterm. So I just wanted to see where you're headed here. After this week, the semester is officially 1/3 over, so it's cruising right along here. Any other questions or problems I could help with before we proceed? Okay, PS4 coming okay? Got some good animations. Look forward to seeing them. Now, I was going to do these slides last time, but I didn't have time, so I'm doing them today. I like at this point of the semester to sort of do a checkpoint on the language so far, what you've learned about Java so far, because it can seem to a student that you're just learning sort of a lot of unconnected details and it's hard to see how they all fit together. So I just want to talk about that for a few minutes. But I also want to define some terminology that I've been using, but I haven't taken the time to officially define. So let's start with this term right here, programming language. Help me out. What is a programming language? You know at least one, yeah?
Java, C++.
Oh, okay, those are examples of programming languages. But I want to know, what is a programming language? Yeah?
Way of turning human language into machine code?
Okay, he said a way of turning human language into computer code. All right, anybody else got a definition? Yeah?
Basically a list of instructions for the computer to execute.
Okay, a list of instructions for a computer to execute. Okay, so here's my definition. A formal language for describing computations to computers and to people. Okay, so what's formal about what do I mean by formal language? Yeah?
There's a lot of just set rules they have to follow.
Okay, there's a lot of set rules. You know, the language is very precisely defined, and you got to put, you know, all the semicolons in the right place. And it's for describing computations, good, to computers and to people. So why do I say that? Why do I say it's for describing computations to computers and to people?
Because the users who have to use the program need to interact with it and understand it as well.
Okay, so it's not so much the users that use the program. What people is it?
It's something the programmer can understand, but that the computer can also understand. Because technically the computer doesn't directly run language, it runs software.
Okay. So it's the people that that you're describing the computations to aren't necessarily the end users, they're the other programmers. In your case, it's the TAs and me. You try to describe computations to. So a well-written program isn't just one that passes all the test cases. It's one that someone else can read and understand what's going on. So there's dual purposes to programs. Okay? So a computer program is a description of a computation written in a programming language. That makes sense. What's a programming environment? What's an example of one? Yeah?
An application or something you use in order to put in a programming language in order to carry computations.
Okay. So what's an example of a programming environment? Yeah? Eclipse, right. So it's an application that helps you write, run, and organize programs, debug programs, you know, keep track of them. And the programming environments that you have today are just amazingly more powerful than the programming environments from 50 years ago. So there's been a huge advancement, not just in programming languages and in computer hardware, but also in the tools that you have available to you. And sometimes that can be overwhelming to a beginning programmer. There's lots of aspects of Eclipse that you're not using and probably won't use this semester. But all the menu buttons are there, so it looks like there's all this stuff you don't know. So you've got to focus on what you need to know. All right. What's an interpreter? That's probably something I haven't mentioned at all. What's an interpreter do at the United Nations? Translates. Okay? So at the United Nations, there are folks that translate. Someone's speaking English. There's people that translate it into languages like Russian and Chinese in real time. So it's a tool that in the case of programming, it's a tool that examines a program and carries out the computation it describes. Right? I'll come back to that. What's a compiler? Yep.
It turns the code that you write into a different form that the computer can actually run.
Okay. A tool that translates a program from one language to another. So the definition of interpreter at the UN, if you had to use one of these terms to describe an interpreter, what an interpreter at the UN does, would you say that that person is an interpreter or a compiler? So the person that's translating the Japanese into the Chinese, is that person listening to what someone says and carrying out the actions described? Or is that person translating from one language to another? It's translated. So that's why it can be confusing to understand these two terms when you already know what an interpreter is at the United Nations. So an interpreter is a computer program, typically, that does what the program says to do. And a compiler is a program that translates one program to another. A program written in one language to a program written in another language. So keep that in mind. It'll become important here in a second. What's machine code?
It's the language of the computer, basically.
Okay, say it's the language of the computer. So every type of computer that you get has a low-level machine code that program, that computer knows how to deal with. It's specific to the computer, yeah.
It's also binary.
Okay, it's a binary language. It's defined in terms of ones and zeros. And it's really not meant to be human readable. Machine code isn't. There's slightly above machine code is what's called assembly code. That's a more human readable form of machine code. So machine code is what's native to a computer. So I'm saying here it's a very low-level programming language that the computer can deal with directly. Java bytecode is also a low-level programming language. And let me tie those together. A computer, one way to define what a computer is it's a machine code interpreter. So there's that word interpreter again. So in what sense is a computer a machine code interpreter? Yeah.
It takes the instruction and runs.
Okay, so it looks at a machine code program and does what it says. So a machine code program is going to say something like, okay, get this value from memory and stick it in this register, and get this value from memory and stick it in that register, and then add the two registers together, and then store the result at this point in memory. So a computer just does what machine code tells it to do. It's a machine code interpreter. It looks at a program and does what it says to do. Now, when you install Java on your computer, you're installing, among other things, a Java virtual machine. So if you want to run Java programs on your computer, you need at a minimum a Java virtual machine. To run Java programs, you don't need a Java compiler, you don't need Eclipse, you don't need the Java library, you need a Java virtual machine. Now, we can describe a Java virtual machine as a Java bytecode interpreter. So what the Java virtual machine does is it takes a Java program which has been compiled into Java bytecode and then interprets it. And the thing about the Java virtual machine is it doesn't matter what kind of computer it is, as long as there's a JVM on it, it can run Java bytecode. It's a different situation from machine code. With machine code, a computer, if it's going to run machine code, it needs to be its machine code. So a computer is a machine code interpreter in the same sense that a Java virtual machine is a Java bytecode interpreter. They both do what these low-level programs tell them to do. So let me try to tie this together, this diagram here. Up there at the top is a C program. C is an old programming language. It's translated by a compiler into machine code. And then to run it, you just say, okay, computer, run this machine code. So we've got the compiler, which is doing the translation. We've got the computer that is interpreting the machine code that's produced by the compiler. And by the way, I say machine code there, but that is actually assembly code. It's just one step above machine code. So there's a translation step, and there's a interpretation step. And with machine code, let's suppose you have two machines with different machine codes. What's it going to take to get a C program to run on both of these computers? You'll have to compile it twice. You have to compile the program once to produce machine code to run on this computer, and you have to compile it again in a different way to get code that runs on the second, get machine code that runs on the second computer. So that's sort of traditionally how compilers work. Here's how Java works. There's a Java program at the top. There's a Java compiler that's run automatically by Eclipse whenever you save your program or try to run it. And it translates Java into Java bytecode, which is shown there. And then, rather than running the bytecode on the machine, we run it. It's interpreted by a Java virtual machine that's running on the computer. So there's a level removed from the hardware. Machine code runs directly on the hardware. The Java virtual machine is a program that is running on the hardware that interprets Java code, Java bytecode. So let's look at the trade-offs here. Which is going to result in faster programs? Okay, why?
Less steps.
Why is compiled C going to run faster than compiled Java? Yeah?
It's like interpreted directly to the computer.
He says it's interpreted directly by a computer. It eliminates the middleman, if you will. It's running directly on the hardware, whereas Java is running in a program. It's being interpreted by a program that's running on the hardware. So you've got this extra level of a program running. Okay, so that's the advantage of a traditional language like C. Now, what's the advantage of a more modern language like Java or Python, which doesn't compile to machine code?
Does it have like methods available for you?
Well, I mean, the languages are different, but
It's a lot faster to develop because it's higher level. And
okay, so there are advantages to the language. Yeah, it's, you know, there are more powerful libraries, more modern language. But what about in terms of this diagram? Let me get back there.
Can it run on more different types of computers?
Okay, the key thing is with Java, you compile it once, and then you can run it anywhere where there's a JVM. With C, if you want to distribute a C program that's been compiled, you've got to have a version for this kind of computer, a version for that kind of computer, a version for that kind of computer. So you've got to manage the different binaries. With Java, there's just one. As long as there's a JVM present on the computer, it can run. Right? So that's sort of a fast look at what's really going on in your program. Now, let's think just for a little bit longer about what we've learned about Java so far. And by so far, I mean through last week, because I meant to use these slides Monday. Java programs, we learned very early on, computes values. A Java program computes values. And we saw there are two kinds of values, primitive values and objects. And there's the full list of primitive values. We've been using int, double, boolean, and char. There are also 4 other primitive types, short and long, which are kinds of ints. Floats, which are kinds of doubles, sort of short, kinds of floating point numbers. And then bytes. And that's all. Then there are objects. And we've looked at various kinds of objects like strings and scanners. But there's lots more in the Java library. And programmers can define new types of objects. We haven't done that yet, but we're about to start. Probably, I'm not sure exactly when, probably after fall break, but we'll learn we've been learning how to create new methods. We'll see how to create new types of data. So that's values. And so when you program, you're dealing with values. That's what you're computing. Okay? You've been writing classes, but for our purposes right now, this is what a class looks like. It belongs to a package. It imports some other classes so it can refer to them. It has a name, and then it contains static methods. Okay? When we learn how to create new types of data, we'll have to change our definition of what a class is. But that's what it looks like right now. If you use a class from a different package, you need to import it. So you might import, like it shows, importing javax.swing.jOptionPane or cs1410.myClass. That's what imports are. Method, it says here a method abstracts a compound action. So essentially, a method takes a series of statements that does something and then lets you abstract it, call it by a name, and use it as a unit. And we've seen two types, void methods and non-void methods. And they're very similar. They have a name, they take parameters, they contain statements in the body, and the difference is a void method doesn't return anything, a non-void method does. So in the last few weeks, we've been focusing a lot on implementing methods. And that's true as well in PS4A. Now, when you write a method, there's a list of parameters that it takes. And this slide is meant to explain that a parameter consists of a name of the parameter and the type of the parameter. And that gives a couple of examples of methods that take. The first one takes an int and a double, and the second one does as well. They're the same thing right there. One's void and one's not. Okay? Statements carry out actions, and these are the statements we've looked at this point. Declaration, assignments, static method calls, non-static method calls, so method calls on objects, return statements, and more recently, while loops and conditionals. And I forget exactly when we talked about for loops, but we'll continue to see more statements as we go along. So statements are there so you can write methods. But the key thing that statements do is control the order in which expressions are evaluated, because that's where all the computing happens, is with expressions. And then these are the examples of expressions we've looked at. We see that you can have primitive values that you write as literals. You can use new to create new objects. You can combine expressions with operators. Variables are expressions. Static method calls can be expressions. And instance method calls, the non-static method calls can be expressions. So that's, in a nutshell, what we've been talking about. That's the language as it stands right now. And it's not that large a set of things. Classes contain methods. Methods are made out of statements. Statements are made out of expressions. And we sort of worked from the bottom up. We started with expressions, then we talked about statements. We started putting statements into methods. The next thing is, in a few weeks, is using classes to create new types of data. Yeah?
I noticed that several examples in the Xi books, when they're doing the declarations, they use final. Where does that fit in?
Okay, so there are various adjectives you can use when you declare variables. Final means this value is not going to change. It's a way of saying it's a constant. So, for example, if you want to put the value of pi into your program, you wouldn't just say double pi equals 3.14159. You declare it final, because the value is not going to change while the program runs. And if you try to change it, the compiler will stop you. Any other questions I could answer? I didn't mean to cover, I'm not really covering new ground here. I'm just trying to organize what we've talked about and put it into context. Okay, so here's something absolutely key. It's not enough. It's not nearly enough just to memorize the stuff on these slides. It's not, you can, let's say you can recite, oh, we have learned about return statements, while statements, if statements, and so on. Or we have learned about operator expressions, literal expressions, variable expressions. That's nice, but that doesn't make you a programmer. What makes you a programmer? Yeah?
Problem solving.
Well, problem solving, being able to take this stuff and what? Well, practice, but what are you practicing? What's the hard part?
Putting it together.
Yeah, putting it together. It's saying, okay, I've got to figure out whether this string is a palindrome, and I'm going to use a while loop and a conditional. It's figuring out how to put all that together and make it work. It's just like, you know, being able to say, okay, there are nouns and verbs and adjectives and adverbs and prepositions in English. That's nice to know, but it doesn't make you a writer. You have to learn how to put the words together. Memorizing the dictionary won't make you a good writer. You've got to, learn how to write and then practice it. Okay? So I'm about to go into some new stuff. I'll give you one more chance to ask anything you want about, anything you might be wondering about at this point. Yeah?
Sorry. What date is the midterm again?
What date? October 16th, I think I said. I just remember it as the Wednesday after fall break. Yes? Say a little louder. Oh, primitive values are, so there are these 8 primitive types of data that are built into the Java language. The ones we've looked at are ints, doubles, chars, and booleans. And so the values of those types are the primitives, like 2 and 3.14, the letter C, true and false. Yeah?
Are there any advantages of using do-while loops, or are we ever going to use them?
Okay, so we've looked at while loops, and we've looked at for loops. There are also 2 other kinds of loops. There's so-called for each loops, which we haven't looked at yet. And the odd thing being that you don't see the word each when you look at a for each loop, but that's what they're called. And the other is do while loops. And we'll probably eventually need to look at a do while loop. But it's anything you can do with any of these loops, you can just do it with a while loop if you wanted to. But a do while loop, just to give you an advance notice, is while loop tests the condition at the top of the loop, do while at the bottom. So do while will always run at least once, because it'll have to run once through the body before it hits the condition. So that it's just when that test is made whether to continue. Anything else? I will say that I probably write 1 do while loop for every 100 loops that I write. I do not use it very often. One reason is I don't like the way it looks when it's indented. It just doesn't look, I don't like the way it looks. So I shy away from it. Okay. All right, here's a new thing coming up. You've been programming in Java here the last 5 weeks, and you have certainly, I'm sure all of you, or most of you, have written code, and when you try to run it, it crashes. Okay? Now, it's really not crashing. What it's doing is, what you've done is written code that throws an unhandled exception. And as you get more experience as a programmer, you'll get comfortable with exceptions. And we're going to start learning about them today. So this slide isn't meant, I'm not going to teach from this slide. You can refer back to it to see what we talked about. I'm going to go straight into some examples and try to explain what exceptions are and how you can use them. So let me get out of the slides, get into Eclipse. Let's start teaching here. All right, here's our first example. So this is a main method. It calls dialogs.show input dialog and gets back a string. Then what it does is, in fact, let me comment this code out, because this is the exception handling code. Okay, so this is the kind of code you wrote the first week. It opens up the input dialog, it parses the string that the user provided into a double, it converts it to Celsius, and then it displays a result. And if we run this program, which I'll do now, if I enter something that's not a double, what's going to happen? Okay? You're going to say, oh, my program crashed. And if you look down here, what does it say? It says there was an exception. It was a number format exception. So look at the first line in the console there. It was saying a number format exception was thrown but was not caught. And there was an unhandled exception. And you get more detail about the exception. It's telling you there that the exception occurred because it was trying to make sense of an input stream that shows you there. And then it also shows you where in the program the exception occurred. So it's showing you that we were running, this bottom line here, we were running in the main method on line 20. It called parse double, which was running on line 549, at which point it called another parse double, which was running on line 110. It called read Java format string, which was on line 2054. These are all library classes. And that's where the exception was thrown. So the exception originated down in the library somewhere, and it wasn't handled, and that caused the program to terminate. So if the main method ever throws an unhandled exception, the program terminates. So we're going to find out what it means to throw an exception and what it means to handle or not handle an exception. So back to here. What happened was this call right here, we called it, but a number was not returned. Instead, an exception was thrown. So the thing to realize is there's two ways a method can terminate. It can terminate by returning normally, which you're used to, or it can terminate by throwing an exception. Now, if it returns a number, we, in this case, if this method returns a number, this is how you capture the number that was returned. You just take the number, store it in a variable, and then you can use it. If the exception is thrown, though, you got to work a lot harder to catch it. So when you deal with an exception, it's referred to as catching an exception. So let me put this code back in now, and you can we can talk about what's happening here. So new statement type is called a try block. So it has the keyword try. Then there's some statements inside a set of braces. Then there's this keyword catch, and then it has statements inside its braces. So this is how it works. When you enter a try block, if you're inside a try block and a number format, if you're inside this try block and a number format exception occurs, then control the exception is caught right here, and control is transferred to the statement. So the exception occurs when we call parse double. These two statements are not executed. Instead, we skip right down to here and execute the body of the catch. So we try to execute the statements in the try block at the top, but if the exception occurs and we catch it, if a number format exception is thrown and we catch it, then we execute the statements in the body of the catch. So what's going to happen when I run the program? What are we going to see if I run the program and enter garbage when I'm supposed to type a number, enter a number? Yeah.
It's gonna put whatever you put in catch, which is invalid temperature, right?
Okay, so it's gonna so let me just show you. We'll see what it does. So it says enter degrees Fahrenheit, so enter some garbage. I say okay. Instead of the programming crashing and burning, it brings up a dialog box that says invalid temperature entered. And I say okay, and the program ends normally. That's called catching an exception. So when you expect that an exception could occur, if you put the code that can cause the exception in try block, then you can catch the exception and do something more reasonable than just having the program die. So it's one thing, in a class like this to have your code die with an unhandled exception. It's not so bad if it's a method library, but if it's a end user doesn't want to see unhandled exceptions. They want to see sort of error messages. Yeah?
Did you declare E of zero before? Because it says catch
Okay, so always get that question, what is E right here? What do you think it is? Well, it doesn't have to be E. It could be, it's just a variable. I could call it X, but I tend to call it E. But what's its value going to be? What's it there for? Well, I'll give you, yeah.
Is it the name of the exception?
No, the name of the exception is number format exception, so we know that, yeah.
When the exception is thrown, does it store the exception and then?
Right, an exception is an object. So when I say something, an exception is being thrown, to throw an exception, you create the exception object, and that gets thrown. So E is that exception object that was thrown that you've just called. Yeah.
Yeah, so does that, the object also contain like a variable that says what line it happened on?
Yes.
I know that you see it down at the bottom there, it says it got thrown out line.
Right, so we can do something like, a very useful method is called e.print stack trace. So the exception carries with it that knowledge of why it happened. And you'll see now when I run it, what it's going to do is I'll enter my garbage. I'll say OK. It says invalid temperature entered, and now it's going to call this method e.printStackTrace, which prints that familiar information in our console for us. And there are other methods that, sometimes there can actually be useful information carried by the exception. There wasn't in this case because just the stack trace. The stack trace is of interest to a developer. It's not really something you want to show a customer though. So one thing you do with the stack trace is put it into a log file. We'll look at it later. Now let's put a breakpoint here and run the program again and see what happens. So we're about to hit the breakpoint. Keep having this problem when I run it the first time. So let's try again. Okay, so we're there at that breakpoint. I'll execute that statement. And I bet you it brought the, yeah, it happens when I debug. It brings it up underneath Eclipse, which is kind of annoying. Okay, so we just finished with that statement. So input is now that garbage, HV, HG, HG. I'm about to call double.parseDouble. What's going to happen when I execute that statement here? Normally, you would think the next statement would be highlighted because that's the next statement. But an exception is about to be thrown, so we end up down in the exception handler in the catch block. And then we execute that statement, which brings this up, and then the program ends. Okay? So that's the basics of exception handling. You call a method that can throw an exception. You can, if you wish, catch the exception if it occurs. Now, how do you know that method could throw an exception or what it is? How do you know that parseDouble might throw a number format exception if you give it the wrong string? Yeah?
It's input from the user, the input, they can put in what they want.
Yeah, but where in the documentation does it say? How would you know the exception is called number format exception? Yeah?
Well, you see what the exception is doing.
Yeah, you could run it once and see what happened and then catch. Or you could just look at the documentation. It says, if the string does not contain a parsable double, it throws a number format exception. If the string is null, it returns a null pointer exception. Now, we haven't talked about null yet. Null is a value. Null is a literal. It sort of stands for, think of it as no object. You can store null into any variable that can hold an object. And let me show you how a null, how this could happen. Let's run this again. But instead of entering something and typing OK, let's click cancel. And what happened when I click cancel? We got a null pointer exception. What happened was, if you look at the Java doc for show input dialog, it says that if you click the cancel button in the input dialog, it returns null. So what happens is when we click cancel, temp F input contained the null value, which we then pass to parse double. And the documentation for parse double says that if you pass it a null string, it throws a null pointer exception. Now, why was the exception not handled? We have a try catch block right there. Why was it not handled?
Is it because it falls underneath the?
Let me get you. Yeah.
Oh, well, actually, I had a question, but the catch is meant to catch number format exception and not null pointer exception.
Right. You have to say what kind of exception you plan to catch, and we're just catching a null format exception. So what you can do is add multiple catch blocks. Now, what should we do if we catch a null pointer exception? It'll only occur when the user types cancel. What would be a reasonable thing for this program to do in the exception handler for null pointer exception? What would you like to see? If you click cancel, yeah? Yeah, just do nothing. So if we do it that way and we run the code, and I cancel, now it catches the exception and it doesn't say, we don't put up a box that said you canceled the exception. We already knew that. Let's try debugging it. See, you can see this, what happens. And let's execute that. Go find my, where'd it go? There it is. So I'll hit cancel. And we go back up here and notice that tempf contains, input contains null. Okay? So we'll explain more about null later, but just think of it as a special value that any variable that, other than a primitive variable, can contain. And then when we call parse double, it's going to throw the exception. So I'll step over that. And we ended up in the catch block, but there was no statement in the catch block, so it just went to the end of the method. And we continue, and we're done. So now we've got it catching two exceptions. Two things can go wrong, and we deal with the two things differently. In the one case, the user made a mistake, and we tell the user. In the second case, the user just clicked cancel, so we can just go about our business. Now, on your next assignment, PS5, you'll be writing some methods and then using those methods to create a main method that interacts with the user in a bulletproof fashion. And by bulletproof, I mean doesn't allow unhandled exceptions. Deals not just with normal return values, but deals with unhandled exceptions. All right, let's take a break for a few minutes and we'll look at some more aspects of exceptions. Okay, here's another example of exceptions. A similar sort of thing. So we're opening up input dialog to get in inches, height in inches, and then weight in pounds. Then we're computing, we're getting those by calling the show double input dialog method. It's defined below. We call that here. We call it here as well. Then we display the BMI. But if there's a number format exception thrown, then we say invalid measurement entered in a dialog. So that's similar to the last example we did. This is the twist I want to show you. Here is the show double input dialog. Up here, we call show input double input dialog, and we are saying it may throw a number format exception, so I'm going to catch it here. But look at this code. I don't see any code that looks like it's throwing an exception. So what's the deal? How is it that this method can throw a number format exception? Yeah. Say what?
If you enter into
Well, but I don't see any code there that does that. Right? I don't see a line of code that says throw an exception. Yeah.
Within the method is the method parse double, which does throw an exception.
Okay. So the deal is, this method calls parse double. Parse double can throw the exception. So if you pass garbage in, parse double is going to throw an exception. Now this method here could, if it wanted to, catch that exception, but it doesn't. So if you write a method that calls another method, throws an exception, and you do nothing to catch it, what's going to happen? Will the program crash? Yeah.
It'll go back to where it was called from the main.
Right. It propagates back up the call chain. So main called show double input dialog, which called parse double. Parse double threw an exception. So show double input dialog gets a chance to catch the exception. If it doesn't catch the exception, show double input dialog goes away, and that exception then is presented to main, which gets a chance to catch it. If it doesn't catch it, that's when the program crashes. So you can call a method, which calls a method, which calls a method, which calls a method to get 20 levels deep of calling. If that exception if that method at the bottom throws an exception, then every method along the chain back to main gets a chance to catch the exception. Any of them can catch it, but if none of them do, eventually main will throw the exception as well, and the program will die. So that's all I was trying to show here, is that you can have chains of method calls, and the unhandled exception propagates back up. Now, this shows something different. Here's a method called sum of tokens. It takes a string, and it's supposed to add up everything inside the, it's supposed to be a string consisting of doubles, and it's supposed to add them all up and return the sum, unless there's a non-numeric token in that scanner, in which case it's supposed to throw an illegal argument exception. So let's see how that works. So we open a scanner to scan from the string. We write this accumulation loop to add up, it says, is there a next double? If so, let's get it and add it in. So it just starts reading doubles out of the scanner, totaling it up. So that's just a standard accumulation loop. What's going on right here? After I've eventually run out of doubles to read, what am I doing? Why am I calling scan.hasNext? Yeah.
It's like the next word in, or next part of the string, is it a number or if it's a word?
Right. So if the string that we're scanning is something like this, 3.15 56.0 hello, what's going to happen is this loop will read the 3.315. Then it will read the 5.6.0, and then it's going to say, does the scanner contain a double? And the scanner is going to say no. The next token is not a double. The loop will end. Then we call scan.hasNext to see, is there a token left? If there's a token left, that can only mean that it's a non-numeric token. And if there is a token left, we're going to say, oops, that was formatted wrong, and we're going to do it by throwing an illegal argument exception. So this is where exceptions originate. If an exception occurs when your program is running, somewhere in a method that you called, there's a throw statement. So think of throw. Throw goes hand in hand with return. Return says return normally, and this is the result. Throw says return abnormally. Throw says terminate this method by throwing an exception. And then whoever called it can catch it if they wish. So if you see a spec like up here that says returns the sum of the tokens of S, if S contains an alphanumeric token, throws an illegal argument exception, then you're probably going to see a throw in there that at certain, when the time is right, it throws the exception. Okay? So that's the throw. You've now seen the throw, you've seen the catch. So this is sum of tokens. There's a second use for a try block besides catching exceptions. And you remember, you've been putting up for weeks with scanners that have a little yellow underline that says, this resource leak. You didn't close the exception. This is the right way to close scanners. This is called try with resources. So here's the thing. When Java was first created, they said, okay, these are the keywords you're going to be using. Try, return, if, while. You can't have variables named try, return, if, or while. They're reserved words. Then they got down the road 10 years later and decided they wanted a way to automatically close resources. And they're stuck. They can only use the reserved words. For backward compatibility, they have to stick with the reserved words that they've been using all along. So they had to repurpose try. So in this form, it's the keyword try, and then in parentheses, you declare a variable to hold an object, a new object that is closable. So some things can be opened and closed. Scanners can be opened, and when you're done with them, they can be closed. Files can be opened and later closed. Network connections can be opened and later closed. So those sorts of things are the things you can open with a try with resources. There's the entire block. You notice there's no catch at the bottom. So the purpose of a try with resources block, it just says when the try block is encountered, it will execute the thing in parentheses and create that variable that contains a scanner. When control leaves the try block for any reason, maybe we execute off the bottom, maybe it returns from inside, or maybe it throws an exception from inside. No matter how we exit that block, the scanner is closed automatically. Now there is a close method, and you can close the scanner when you're done with it manually by calling scan.close. But what's the advantage of doing it this way instead of explicitly calling close? Yeah.
If for whatever reason your code never actually reaches that point where you tell it to close the single close.
Okay. I think you said more or less the right thing. How many ways are there to exit this try block? Say we're executing along, single-stepping through. What would cause execution to leave the try block? Yeah.
When the if statement either goes to the first or the else.
Okay, so it could exit here. So if we need to say, okay, before we throw the exception, if we're not using try with resources, we need to call scan.close. And it's about to return. We better call scan.close. And then I don't think it's possible here, but in general, it's possible you could execute out of this try block normally if we didn't hit a return. So we might want to put scan.close here. And then you start wondering, what if next double for some reason throws an exception that we don't handle? How am I even going to close the scanner in that case? Now, it's telling me there's an error here. It's telling me that we can't reach this code. But my point is, rather than trying to figure out all the ways that control might leave the try block, don't worry about it. Use try with resources, and it'll automatically close the scanner whenever that happens. You don't have to foresee the future. So you open it in the try with resources block, and then it'll close for you when you're not using it anymore. Yeah?
Could you maybe give us an example of a problem that would arise if we left the scanner open?
Okay, so he's asking for a problem that occurs when a scanner is left open. If you're scanning from a string, there's no problem. The problem occurs when you're scanning from a file. We haven't looked at that yet. But you can create a scanner that's reading its tokens from a file. And until the scanner is closed, the file stays open. And if my program has a file open, your program can't read that file. So a program that opens files and never closes them is kind of unfriendly. And there's also a limit to how many files a program can have open at the same time. And you can run up against that limit as well. So what's important is that files be closed, or that socket connections to the internet be closed. Limited resources need to be closed when you're done with them. Now, in this kind of try with resources, you can, if you wish, add catch blocks at the bottom. You're not required to, but you can have catches optionally if there are exceptions you want to catch in addition to having your scanner closed. Okay, this talks about checked exceptions in the throws clause. I'm gonna skip over that and come back to it on Monday because there are other things I want to talk about. Okay, let's look at this example here because this is going to be important to your assignment. It says obtains a number from the user and displays its square root. Allows the user to cancel and reprompts when an invalid number is entered. So the difference is, from what we've looked at before, if the user enters garbage, we want to tell them and then let them try again instead of just ending the program. So how can we accomplish that with a try block? So we got the basics here. We ask the user for a non-negative number. We parse it. We display its square root, and then we end. But what if the user makes a mistake or clicks cancel? Yeah?
Is there a way to have the exception thrown just restart at the beginning of the program so it just kind of loops it?
Okay. He's asking, is there a way to cause this code to repeat? Not with a try block, but how could you do it? What's a way to get a block of code to repeat? A loop. So what we can do is do this. We're going to write an infinite loop on purpose here. Now if we do that, that's not quite what we want. It's going to prompt display, which isn't what we want, but it's a start. So what should we do if the user sees that, enters the good data, it gets parsed, and then we display the message? What should we do next? It could end the loop, end the method. I'm just going to do a return. So if everything goes as planned, we're just going to bang, 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 return. The loop will end, the method will end, the program ends. Now, what if the user causes a number format exception? What do we want to do? We want to give them a chance to, what I want to do is display an error message and then give them a chance to to try again. So how can we accomplish that? Yeah?
You could throw an exception, and then after you throw the exception, do another dialog box.
Okay, so we're not going to throw the exception, we're going to catch it. We're going to catch that number format exception. And if we see it, we're going to say dialogs dot show message dialog. Bad number, try again. Okay. So what's going to happen when we run this program and enter a bad number? Yeah?
I'll give you the prompt, but I don't know if it'll go back.
Okay, so it'll go along, it will show the input dialog, it will try to parse it, an exception will occur, so it'll display the message dialog, and then it will execute out of the catch block and out of the try block. But it's inside of a while loop, so it'll just do it again. And the only way we get out is to return out. So let's try that out. So here I am, enter garbage, I get the OK, it displays a square root. How did that work? Did I type in a number? Okay, so I'll type garbage that time. It says bad number, try again. So I'm inside an infinite loop. If I finally type in a number, then it displays it and then hits this return, which ends the loop, ends the method, ends the program. Yeah?
Could you show what would occur if you give me a negative number?
Okay, let's see what happens if we enter a negative number. Negative that, we say OK, and we get out square root is not a number. Okay. But what happens if we do this? What if we run it and hit cancel? What's going to happen? It's a null pointer exception. So how can we, what we want to have, if the user hits cancel, we want the loop to end as well. So how can we accomplish that? All right, we catch it down here. And what should we do when we catch it? Return. So now, if I enter cancel, it just gracefully ends. So this is sort of like a user interface loop. Pretty common construct when you got to keep reprompting the user, figuring out what they did wrong and deciding what to do about it. So it's a kind of a use for an infinite loop. Yeah?
Can an or be used in one of those catches so that it can catch either or?
Yeah, so it turns out if you want to catch either a number format exception or a null pointer exception, you can do that. And that'll catch either kind of exception, but we don't want to do that in this case because we don't want to do the same thing for both exceptions. But if there are two exceptions that you can catch and do the same thing for both, you can combine them with that vertical bar. But that's not what we need to do. Any other questions? Yeah?
When you combine those, what exactly is that single type? How's that interpreted?
That's just the operator symbol. You asked me about the vertical bar when I put the two exceptions together. That's just the notation that it uses to say this exception or that exception. Yeah.
So when you do like the loop, don't you have to have two?
Oh, you're right. That's why I don't really want to call it an or. If you're doing a logical or, it's two vertical bars. If you're saying this exception or that exception, it's one vertical bar. It's just one of those details. They didn't want to invent. They couldn't invent a new keyword for it, so they're just reusing. Any other questions? Okay, now I'm going to finish up with a new type of object that you're going to need to use next week. And it's called the Arraylist. So we looked at arrays last time. And arrays are built into Java, but they have this annoying property that they're fixed length. They can't grow and shrink. Java also has a class called the Arraylist class. And it basically provides lists that can grow and shrink. So it's handy to know both. Sometimes you have no choice but to use arrays, or there's perfectly fine. Other times you want things that can grow and shrink. Now, array lists are a first example of what's called a generic type. And if you look at how you declare a variable A of type array list string or array list integer, looks kind of weird. You see the angle brackets? So that's a type name that has those angle brackets is called generic type. So we're just saying, if you want to say, I want an array list can hold strings, you put the hold strings part in the angle brackets. There's more to say about that, but I just want to hit the basics today. So this is how this right here is how you declare a variable of type array list. So you can compare that with how you declare an array. This is how you create a new one. So if you want to create a new empty array list of strings, you do it like this. So it's new, type name, and then empty parentheses. So you're calling the array list constructor. That gives you an empty array list. If you want to extract element 6, you do the get method. If you want to change what's stored at element 5, you use the set method. If you want to find out the length, you use the size method. And then there's also this neat little add method, which adds to the end. And then there's a remove method that removes, in this case, from index 4. So the notation for arrays is much more compact than the notation for array lists. But array lists have this powerful advantage that they can grow and shrink efficiently. Arrays can't do that. So let's play around with array lists in JShell. I guess this will work over here. So suppose I want an array list of strings. It takes a lot of typing to do that. Okay, so there's A, and it kind of prints out nicely for you so you can see what's in it. Right? Now, at this point, I've got an empty array list. So what's its size going to be? That's 0. There's nothing in it. Now, what if I say, give me element 0? There is no element 0 because the thing is empty, so I'm going to get a index out of bounds exception. Okay? What if I wanted to put something in the array list at index 0? Add. So if I say add 52, wait, this is strings, isn't it? Now if I say a.size, it's going to say 1. If I say a.get at index 0, it's going to say 52. If I say a.get of 1, it's going to say no such index. Right? So now I can do a.add of Joe. And if I ask what's A at this point, JShell will show me it contains a string 52 and the string Joe. And that's the basics. You can remove. If I want to remove element 0, I do that. And now if I look at A, it's just going to contain Joe because we've taken element 0 out. So they can grow and shrink. You can also add tell it where to do the add. So if we say added at index 0, never mind that. I got them in the wrong order. At index 0, add x. And it goes there. So I'm telling you this because, well, they're important. We'll be using them a lot, but they're going to also be used on PS5, so it's important to know. So I at least want to get this out, and then I can go back to my slides and show you some more stuff. But fundamentally, they're not hard to use. You just got to know what the methods are called. But I want to show you one tricky thing about them. Suppose you would like an array list of ints. It would seem that you would do it this way. But here's the problem. the thing that occurs between the angle brackets is not allowed to be a primitive type for no good reason. Well, there's a reason, but it's an obscure reason that I don't care to go into. So you can have array list of strings, you can have array list of scanners, an array list of fonts, array list of files, anything that's an object type. You can have array lists of, but you cannot have array lists of ints because ints are primitive values. And that seems like a pretty bad thing. Yeah.
So do the wrapper classes work now?
That's what wrapper classes are for. So they sort of, the problem is they added these generic types to Java, 5 or 10 years after they created the language. And they couldn't get it in as smoothly as they wanted. I once had dinner with Bill Joy, who was one of the designers of Java, and I asked him why they didn't put generics in at the start and get it right instead of adding it later and having to do this compromise. And he said they basically ran out of time. They had a deadline they had to meet, and they didn't get generics in as a result. They wanted to, they didn't get them in. So, here's the story. I really hate that I have to tell you this story because it's just an annoying fact of programming in Java. For every primitive type, there's a class type, a reference type, that goes with it. And even this, I think, is stupid. If it was up to me, I would have the wrapper class just be the uppercase version of the primitive type. So, hey, it works for double. The wrapper type for double is just double with a capital D. For Boolean, it's Boolean with a capital B. But for char, it's character with a capital C, and for int, it's integer with a capital I. That annoys the heck out of me. Why couldn't they at least be consistent here? All right. So the point is that if you want to have an array of ints, an array list of ints, you just have to say, I want an array list of integers. You just have to know that wrapper type exists. So let me go back and show you what you have to do to get an array list of ints. So instead of saying int there, you can say array list of integers. And I'm going to show you something else, just because I get tired of typing. Technically, you're supposed to put the integer in the angle brackets there, but the compiler can figure out what you're talking about. It knows you're creating an array list of integers, so it'll let you get away with that. It saves you a little bit of typing. So there's B. But now, if we want to put something into it, we can stick an int in there. And what's happening is the Java virtual machine, the compiler, is taking that 4, which is an int, and converting it into an integer object and sticking it in there. Then when we go to get it out, let's see what comes out. It unboxes it coming out as well. So you go to get the thing out, and rather than giving you back an integer object, it'll give you back an int if that's what you need. So it does the conversion back and forth automatically. 99.9% of the time, these generic types will behave just like you want. If you mean int, just type integer in the generic definition. If you want char, use character. If you want double, use a capital D. What's really happening is, this is happening. If you give it a 4 to add to that list, it's automatically going, create me a new integer object that contains the primitive 4. And then, let me store it somewhere. And then when it comes out later, it does n dot, I think it's called int value. So that's all happening behind the scenes. You don't have to worry about it 99.9% of the time, like I say. Or something, every now and then something will come up and bite you, usually with ints. So I hate that using something as useful and powerful as an array list involves having to explain this annoying detail of Java. But my advice is don't worry about it. Just when you mean int in a generic sense, like up here, just write integer. Now, having said that, I've seen people doing this in programs. They'll say for integer I equals 0, I is less than I is less than 100, I plus plus or something. No, I didn't mean to type that capital, but you get the idea. Okay. Or they declare a variable like this. Double pi equals 3.14. And everything works. But I cringe when I see that. If you mean double with a lowercase d, don't put an uppercase d. What's the disadvantage of writing double pi equals 3.14? As opposed to using a lowercase d. Yeah?
You have to instantiate the object before you use it.
Right. So rather than just storing 3.14 in a variable, which would be the case if you say double x equals 3.14, that's just more efficient. The thing I just typed is just going to store 3.14 in a variable. The thing that I typed before is going to take the 3.14, then it's going to automatically create a double object to hold the double, and then store it in the variable. Then you want to use it, it's going to have to turn around and take it out. That's called boxing and unboxing. It happens automatically most of the time, but it's still inefficient. There's no reason, if you want to double lowercase d, don't misspell it as capital D. All right, I feel like I've just spammed you with a bunch of detail, and you're wondering why I'm mad at you today, but fundamentally array lists are simple. You add, remove, size, and you just got to remember this one caveat. You've got to spell int differently when you create one. All right, I've said enough. Let's end there, and I'll fill in some more details I've skipped over on Monday.